different types of meteorites and what we've learned from them about the formation of Earth and the solar system. The thing is, what's especially interesting about meteorites is that they come from interplanetary space, but they consist of the same chemical elements that are in matter originating on Earth, just in different proportions. But that makes it easier to identify something as a meteorite, as opposed to just a terrestrial rock. So, to talk about where meteorites come from, we need to talk about comets and asteroids, which basically, they're basically made up of debris left over from the origin of the solar system 4.6 billion years ago. Now, I'm going a bit out of order here. I'm not going to go into any depth on comets and asteroids now, but we'll come back later and do that. For now, I'll just cover some basic info about them. Okay, comets and asteroids. It might help if you think of... Remember we talked about the two classes of planets in our solar system and how they differ in composition? The terrestrial planets, like Mars and Earth, composed within metals, and the large gas giants, like Jupiter. Well, the solar system also has two analogous classes of objects smaller than planets, namely asteroids and comets. Relatively near the Sun, in the inner solar system, between Jupiter and Mars to be precise, we've got the asteroid belt, which contains about 90% of all asteroids orbiting the Sun. These asteroids are like the terrestrial planets in that they're composed mostly of rocky material and metals. Far from the Sun, in the outer solar system, beyond Jupiter's orbit, temperatures are low enough to permit ices to form out of water and out of gases like methane and carbon dioxide. Loose collections of these ices and small rocky particles form into comets. So comets are similar in composition to the gas giants. Both comets and asteroids typically are smaller than planets. An even smaller type of interplanetary debris is the meteoroid. And it's from meteoroids that we get meteors and meteorites. Roids are, for the most part anyway, they're just smaller bits of asteroids and comets. When these bits enter Earth's atmosphere, well, that makes them so special that they get a special name. They are called meteors. Most of them are very small, and they burn up soon after entering Earth's atmosphere. The larger ones that make it through the atmosphere and hit the ground are called meteorites. So meteorites are the ones that actually make it through. Now, we've been finding meteorites on Earth for thousands of years, and we've analyzed enough of them to learn a lot about their composition. Most come from asteroids, though a few may have come from comets, so essentially they're rocks, and like rocks, they're mixtures of minerals. They're generally classified into three broad categories: stones, stony irons, and irons. Stone meteorites, which we refer to simply as stones, are almost entirely rock material. They actually account for almost all of the meteorite material that falls to Earth. But even so, it's rare to ever find one. I mean, it's easier to find an iron meteorite or a stony iron. Anyone guess why? Look at their names. What do you think iron meteorites consist of?
Mostly iron?
Yeah, iron and some nickel, both of which are metals. And if you're trying to find metal...
Oh, metal detectors.
Right, thank you. At least that's part of it. Stone meteorites, If they lie around, exposed to the weather for a few years, well, they're made of rock, so they end up looking almost indistinguishable from common terrestrial rocks, ones that originated on Earth. So it's hard to spot them by eye. But we can use metal detectors to help us find the others, and they're easier to spot by eye. So most of the meteorites in collections, in museums, they're iron meteorites, or the stony iron kind, even though they only make up about 5% of the meteorite material on the ground. Okay, I want to